So then can you go a little bit into detail of the work that we're doing at Nabla Zero Labs as far as the Artemis missions?
Yes, um, we are supporting three main areas. The first one is in the numerical methods and algorithms for trajectory optimization. Uh, we are developing a software suite that we already gave it a name. It's called MAD, the Moon Ascent and Descent Tool. And the purpose of that one is to enable a very accurate, optimal trajectory design for the descent on the moon and the ascent from the moon. The reason why we need a special tool to do it, as opposed to using some commercial off-the-shelf tools that are available, is because every little part of the trajectory is subject to different constraints. These constraints are expressed in many different ways. Some of them can be rates, rates of change of certain parameters. Others can be orientations. Others can be the rate of the change of the orientations. And other ones have to do more like with the humans. Like, for example, that the human needs to be able to see the ground as they are landing. And others that have to do with targeting the Orion, the main spacecraft, as we take off. So this is a complicated mathematical problem, and the tools that exist can target a few of these variables, but not all of them, unless you do some workarounds, which is one problem. And the other problem is that it's slow. And because we have different standards for reliability and security, etc., we want this tool to be able to perform massive number of simulations to make sure that we cover all the space and do it very rapidly. So that's one area of support. Another area of support is with the development of their entire tool chain to perform mission analysis and spacecraft operations. So we, as you know, we know well how to use established tools like Monty, for example, for navigation and mission design. And the national team that we support needs to get up to speed very quickly. They do not have time to experiment or to reinvent the wheel. So essentially, they need something that is proven. They maybe need to look at a couple of options, but they need to take quick decisions and move fast. So that's our secondary of support, that we establish a set of analytical pipelines for them to evaluate and just quickly tweak to serve their needs and just have their team up to speed in a minimal amount of time. And the third one, which we haven't started yet, but we are going to get there hopefully, is in everything that has to do with planning and scheduling. When everything gets married together, the different phases of the mission with the schedule of the humans, with the schedule of the antennas, with the schedule of the maneuvers, you're going to end up with this massively complicated scheduling problem where everything has to fit in its time slot. It cannot step on anything else. And it has implications that fall like dominoes. So we're going to provide, we have designed in the past some tools and some techniques to manage these very complex scheduling problems. And we hope to provide it to them. So those are the three. In general, is astrodynamics, high performance computing, navigation, and analytical support. That's what we've been doing for over a year now. And we hope to continue supporting throughout the design of the mission and on to launch and operations.